Hello, good morning. It is Friday, December 13th. Oh, crap, it's Friday the 13th. Maybe I shouldn't stream or try to do any real work today. Just kidding. I don't care. I'm Rob, that developer dad, and I am working in C Sharp and .NET to do a whole bunch of stuff. Um, about 7 months ago, I got laid off from my programming or architecting position at a very large consulting company. They were just trimming payroll, and I got the dubious pleasure of getting to participate in that payroll optimization. You're welcome, shareholders. I decided to make lemonade out of those lemons and started streaming and trying to teach some of the things that I've learned over my pretty long career in software development. I've been at this for over 20 years at this point, all of it in the Microsoft space. And I started just like coming up with programs to write. And one of those programs actually kind of stuck. I had developed a AI-assisted townsfolk generator for my D&D game because I run a D&D game, or I was running a D&D game at the time. It's currently on pause because two of my players just started college and they don't have any time for anything fun anymore. Um, and they kept like these guys were serious role players, so they want to strike up a in-depth conversation with every single person they met in my game world. And I was running out of names that I could pull out of my butt and details and so on and so forth. So all of my blacksmiths started being called Seamus from under the mountain, and I my tavern keepers were all buxom redhead flirty girls, and it just they didn't seem to care, but I did because I want to provide a really rich world with unique characters and everything like that. So I was like, you know, these we're just picking random items from lists at the beginning, and then we're decorating those, we're using those random items, which can act as keywords that could be injected into a prompt. And I could ask an AI to actually write some frilly descriptions. So I wrote it, and it was awesome. And then they were like, gosh, I wish this was an app. So I built a front end for it. And then they were like, gosh, I wish I could use this. So I figured out how to deploy it to Azure. And now I need to figure out how to be able to accept their money and then automatically update their subscription every month to give them new AI credits and so on and so forth, and blah, 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 blah. And that brings me to what I'm doing now, because all throughout this, I have been promoting the architecture style that I was taught several years ago at a course by a guy who Microsoft's development people call when they get in trouble. And he's developed an architectural method and a way of making software happen that really resonates with me personally. And there's a lot of aspects of that that make a whole lot of sense, but they can get kind of painful when it's time to type in the code. So more recently, I've been working on a sort of generic system framework that kind of makes the need to write that code. It's all plumbing code, kind of makes it go away when I'm actually authoring my system components. And this week I've added a generic filtering component, so I can filter collections of whatever type I'm dealing with in my system. And then on Tuesday or Wednesday, I started tackling the mapping problem. When we're dealing with multi-layered architectures with multiple vertical slices and so on and so forth, we're going to end up with a lot of classes. And many of those classes are going to represent different views of the same overall idea, abstract concept, right? And so domain-driven design is a philosophy. It's sort of a design slash architecture philosophy that helps us kind of recenter human language in the software design and development process. And I really like a lot of the ideas that domain-driven design brings us. Some of the implementations I've seen have been difficult to work with and perhaps don't stand up to the stresses of an enterprise environment. Hey, what's up, Akram? I'm just sort of doing my my morning lecture spiel thing. So a lot of the alumni of this architecture course that I took several years back talk about being able to marry domain-driven design ideas with this architectural method that we've all been taught through the courses, or now we're getting a lot of people that have read the book that this fellow wrote. And I'll put the name of the book and the author in the chat. It is, in my opinion, one of the best books about technology and making technology that I've ever read. Software by Yuval Lowy. His company is iDesign.net. And the courses ain't cheap, but good golly, absolutely worth it, especially if you can go in person. So with these domain objects, like we'll have a conceptual domain object, very abstract, like a customer or a subscription or what have you. And we're going to be tempted to build one big gigantic class that has all of the information that we could ever want about that concept that our company deals with in our processes. And that's a mistake, because when you do that, you're tying every component in your company's software into one thing, and you end up with either a very tightly coupled monolithic application, or even worse, you end up with a tightly coupled distributed application that might as well be a monolith, but with more steps and way more pain. So what if we were to take this customer concept, and instead of having one gigantic, omnipotent, omniscient object that represents that customer, what if we identify the aspects of that concept that apply to subscription management, and the aspects of the concept that apply to, say, what the actual application needs to know about that customer while the customer is using it, so their profile, what aspects of that customer object do maybe other users need to be able to see or should have access to if we decide to add some social aspects to one of the software products that we produce, like the ability for somebody to, say, create an NPC in their subscription and then make a copy of that NPC available for other people to use, or to share it with selected other users of the software, things like that. Having all of that stuff on one big gigantic object is going to make maintaining every single piece of my software a gigantic pain in the butt. So what I've come up with, and the term that I'm settling on, is idiomatic type, where each section of the application, each subdomain of the overall domain of the systems that I'm building has its own set of idiomatic types that represent that very abstract domain concept. And then, of course, within the vertical slices, within the different pieces of software that serve my domain, I'm going to have different views of what those types might look like. For instance, a customer for, or the view of the customer that a storage component has may be very, very different from the view of a customer that a subscription builder component might have. And they're certainly different from the view of the customer that's presented to the public via a public web API. Now they're all the same thing, but we can't work with them directly from one component to the next. So we need to be able to map between those different versions of the customer or the subscription or the NPC townsperson or what have you. And that code can get, well, it's boring. It's boring to write. It's repetitive. You fall asleep at the wheel. And when those three things happen, bugs will come and lay eggs in your software. And then they're going to pop out and do horrible, horrible things 6 months from now. So whenever we have something boring that's approximately the same every time you do it, what do? Automate it. So earlier this week, I started building a thing called the Domain Object Mapper. Now, this thing doesn't have any knowledge of the actual objects in my system or the business logic or any of the activities that my system does. Instead, what it allows me to do is, oh yeah, you yelled automate it, and you were absolutely correct, 9 to 12. She's not a programmer, but she's been living with one for 25 years this coming Sunday. So yeah, she knows my battle cries. So I created this DomainUtilities namespace inside the IFX project here. And I've defined a couple of attributes. Number one is the domain entity attribute. And all it does is it allows us to decorate any of the classes out in our actual code components with the name of the conceptual entity that they represent, what service archetype this idiomatic type belongs to. So whether it belongs to a manager, an engine, an API client, an API server, a resource access type thing. And I should probably add another one for storage model. We'll see. And then, of course, the domain subcontext, which is completely optional for when an idiomatic type should only be used within a specific domain subcontext. So finance, analytics, customer support, user features, things like that. Because like finance isn't going to care about the details of a townsperson that one of my users created. Customer support might. Other users might. Yeah, absolutely. 9 of 12 is at least as smart as I am, just differently so. So we've got these domain subcontexts, completely optional. I haven't used it yet, but I have the facility in there for when I do. I may not even need it for these projects, but I'm going to run into it eventually. And it's defaulted to star, so that basically means it can be used across all domain subcontexts. And then, of course, we've got this entity attribute, which allows us to provide the conceptual name for the property of one of our domain entities. We can define whether this attribute is a collection of values versus a single value. And we can, if it's a complex property, or rather the attribute is actually an instance of some other entity or domain entity, we can identify that here. And here's my constructor. The only thing we have to provide when we assign this to a class property is the attribute name. The default for collection is false, and the default value for value entity name is also it's null. And if we don't see this, we just go with the type on the property. I'll show you how it looks. Let's come over to the managers. Pop this guy open. We'll go into the contracts, and we'll take a look at the customer profile. So we see here that my customer profile represents a domain entity called application user. Now, I've stuffed all of these strings into some specialized classes in the product framework, which is different from my organizational framework. We'll get to that in a minute. Now, the product framework typically holds values that are specific and global to the entire code domain. So this guy is an application user. It's declared by a manager component. The user ID property maps to the user ID entity attribute. Display name, display name. We've got the subscription status. And now you've seen so far with these three, they all kind of match. And they all might continue to match even in other idiomatic types. There's that word I've been using. That's a base class that provides some built-in functionality that all classes that call themselves idiomatic types automatically get. Thank you, inheritance. So then we get down here where we've got a special case. I've got a collection of external ID objects. Now, in the domain, I call these correlation IDs, which allow me to correlate an instance of my customer profile with another entity in a remote system. For instance, Microsoft Entra, or if I were using Stripe, my users or my paying customers might have an account number at Stripe. So I need to keep track of what all of these IDs are so that when this program needs to call out to Entra to make sure that the customer is in the appropriate user groups, or I need to call out to Stripe because it's time for them to renew their subscription, so I need to kick off that transaction. I can get the appropriate ID for whichever system and just include that in my request to that system. And because this is going to be, this concept exists throughout the domain, I've created the external user ID domain entity and given it some attributes and so on and so forth. So this guy is a whole lot simpler than my customer profile. So let's take a look at the external ID definition. Here's that. We can close customer profile. So we see here, external user ID. This idiomatic type is owned by one of my manager components. And we've got remote system name as the conceptual attribute. We've got ID at remote for the conceptual attribute, and those are materialized as vendor and ID at vendor. So that's great. This is just one class. Why the heck do I need to do all of this work to get one class decorated like this? Well, because I need to store those things in some kind of storage mechanism. And in the case of this application, I'm using Azure Table Storage, but the abstractions of my user account access components doesn't care where they go. I originally had them in like Azure SQL database, And then I discovered that Azure Tables was going to be way, way, way cheaper by several orders of magnitude cheaper and just as quick for my use cases. And I didn't need all of the relational goop. So I switched over to that. But that's largely irrelevant. I still need to have stable definitions of what my user account or my customer profile or customer account or whatever I've called it, the domain entity. I still need stable definitions for what these things will look like in terms of a access component, because what these things will look like when they're stored is going to be completely different from what my application needs them to look like. So let's take a look at I have a user ID resource right here. So over here, different class, same concept, same domain concept. So what I've done is I've decorated this to say, this is an idiomatic type of the external user ID domain concept or domain entity I'm using. This idiomatic type is owned by a resource access component. Vendor name, user ID at vendor. These properties map to remote system name and ID at remote. So we know that these types are equivalent at a logical level. I don't have a formal class called external user ID anywhere in my system. Well, that's sort of a lie. I don't have a class that you can perform operations on or create or anything like that. What I do have over in my application framework is just a set of static classes that do nothing but declare constants. And I put all of these classes into this partial class called SASDomain, and that defines the entity, the conceptual entities that are used by the domain of this program. And I've got external user ID, and the only reason these classes exist is because I don't want these magic strings everywhere in my code. Because if I have them exist as just strings, if I decide that I need to change the name of any of these entities or any of these attributes, I have to find every single bloody place in my code base that uses this string and change it. But by using this construct, I get this nice, tidy, I can navigate through it way of doing stuff. So I don't have to remember what those strings are. I can just I know that they live in the entities, and I know that I can just navigate through all of the different entities that I've defined over in the framework. I just saw a text from 9 come in, but I don't have eyes on it. Give me a second. I'll deal with it after. It's game stuff. All right. So what does this let us do? Well, we've got this domain object mapper, right? Let me come out to the customer builder. So when I'm building out a customer profile in the manager, because the manager doesn't actually do any real work, it doesn't do any serious thinking or data access or anything like that. It's quite literally a manager. It delegates the tasks to specialist components that are very, very good at those tasks. And then it accepts the results of those tasks, assembles them into whatever they need to be assembled into, and then presents the results to the client, just like a manager. So what I used to do up until I decided I'm sick of doing this nonsense, this is a pain in the neck, and I don't want to do it anymore, is just write extension methods that map from one type to another known type. And I'd have to be very explicit about everything and very manual. And if I ran into a complex property, I'd have to write another extension method for that. So I'd come down here and do all of this stuff. And oh, look, there's another nested complex property. So we got to go write another extension method for that. And I'd write reams and reams and reams of boring, repetitive mapping code. And then I'd have to spend just as long debugging and finding all of the mistakes I made because it's boring and I fell asleep at the wheel. So I've been wanting to do this for years, but I've always been working on somebody else's dime, and so that means I'm working on somebody else's priorities. So I spent a couple of days, and over those couple of days, I'd say I've spent maybe, in terms of actual coding and getting this thing polished, probably about 12 hours. 12 hours of my work. Didn't get any new features out of it, but 12 hours of my work. You saw that I just deleted that call to the extension method because I've got the customer profile decorated as that user account or application user. And then I've got the user account resource decorated similarly with the same domain entity and the same domain attribute values as they apply. I don't have to use those extension methods anymore. Instead, I could just call domain object mapper dot map entities and then pass in the source and the destination. Let's take a look. I'll save the customer builder. We'll run the app. Now, yesterday in the last session, I was able to get any of the simple property mapping just completely automated as configured on the actual data contract classes. Collection properties and complex properties weren't working. I knew that they weren't going to work with the code that I had already written. I knew that I was going to have to put in a lot more effort to get those cases to behave as expected. So here's map entities. And I did that work offline. We're going to review it in a second because we're going to get to it. So if destination instance is null, we're just going to create one right now. We already created it outside in the customer builder, so we're just going to apply the values that come in on my source instance. We got to make sure that the idiomatic types that we've provided are idiomatics of the same domain entity. So we've got this guard types are equivalent. Let's step in. And here, because I've got instances, I've added some helper methods on that base class that I talked about that query each instance of an idiomatic type is able to query its own attributes and get those lists or get those values in those lists for us. So I don't have to have special code anywhere else for that kind of thing. So we've got source instance.entity name is application user. Application user, we're clear. Good. Now we get all the entity properties. And all this is a name of the entity attribute and the object that represents the type property. It's .NET Reflection stuff. It allows us to look at the actual, when the code is running, it lets us look at the actual code that makes up these things that we're doing. And that comes in super handy when we need to do some different things with that code. So we've got source map and destination map. So we've got all of the properties on each of these types that have been decorated with those entity attributes. And now we find out what attributes these types have in common with each other, because those are the only ones that we really care about here, or rather that we can deal with here. And now we just loop over all of the attributes in this common keys. And we should have it materialized as a list now, non-public members. Okay, yeah, it's just going to be a pain. That's okay. There's like 4 or 5. Now, the first ones are pretty plain Jane vanilla, strings, numbers, dates, etc. There might be a Boolean in there. So we've got our source value for the first property. And that looks like a user ID to me. So let's go into convert attribute. So here we are in convert attribute. We've gotten the object that we're copying all of these values to in destination instance. The source value is the value from the property on the source object. And then, of course, there's the information about the source property and the destination property. Because they might have different names, they might have slightly different types, but they can't be too different. Otherwise, we're going to get in trouble. So entity attribute, source property, we have to get that custom attribute again so that we can ask some questions about it. We need to create the destination value just as like an object because we don't really know what it's going to be. And we say, has the destination been assigned yet? No. So if the property type of our source can be assigned to the property type of our destination, that means if we've got a 8-bit integer going into a regular 32-bit integer, yes. If we've got a 32-bit integer value going into an 8-bit integer value, the answer is no. Strings can be directly assigned to strings, yada, yada, yada. And here I know that the property type on the source is a string, the destination is a string. So we'll just step in. Destination value is copied from source value. We say the destination is assigned, so we can skip over those next things. And while we're here, I'm just going to drop a breakpoint here and a breakpoint here. Because after we've seen what happens here, and then if we get down here and the destination hasn't been assigned yet, I'm just going to throw an exception. We're going to set the value that we've determined for the destination value on the destination instance and return it. So our destination instance should be a customer profile, and we've just added that user ID. So we've got a few more properties, and then we're going to hit something a bit more interesting. So I'm going to hit play. Boop. And now we have to deal with a collection because our source property is, where's the name on this guy? Module name is external IDs. And we know that external IDs is a collection of one of our domain entities. If you remember back to where I showed you that a few minutes ago. So we're dealing with a collection. And collections, oh boy, what a pain in the neck to deal with in terms of mapping via reflection. So if source value is null, we're not going to do any more work. But I know the source value isn't null. There's no sense going through all of this reflection work and all of that stuff when there's actually no value to assign to our destination. So first thing we have to do is we have to figure out what this is a collection of. And that's what this line does. And my source element type is user ID resource. And now I need to turn that source value, which right now is just an object, which basically tells the runtime it's something, but I don't know for sure exactly what it is. It's definitely a thing. And so here we're saying treat the thing as a group of things that we can enumerate over. That's what this does. So our source collection is now enumerable, which means we can put it in a loop. Our destination element type, well, right now the destination element is some kind of thing that might be nothing. So we got to figure out what that type is supposed to be. We want to take that collection of some kind of things and turn it into a collection of external IDs. And now we can create a generic list of something. So we've got the type of list that we need to create here that we can actually put the things into as we convert them is a list of external IDs. And here's where we just create it and turn it into a list that we can work with. Now this won't always work, and sometimes we'll end up with null on the destination list. And when that happens, out we go. We're going to crash. Now, because we're iterating over a collection, we're going to be running the same code every time we hit the next item in that collection. And if we're not careful, if we write that code so that it's too expensive to run, like it takes too long or it gobbles up all kinds of memory or whatever, it can really start to suck after a while. So I want to do some things here to maybe reduce a bit of that suck factor on the computer that's running it. So the very first thing I do is I say, okay, for the elements in this source collection, can I just directly map these elements to the destination collection? And that's what this does. And I'm just saying, I'm storing the yes or no for that question in this can direct map value. And in this case, the answer is no. But if I were mapping a list of strings to an array of strings, or a list of some kind of number to a collection of some other kind of number or whatever, we'd probably have a yes there, and we could just do add the element. Instead, because we're dealing with complex types in the source and destination collection, we actually have to convert the entity value. That's another custom method that I wrote yesterday. We're going to step into this in a minute. So destination element equals convert entity value. Our current element is a user ID resource. The source element type, user ID resource. Cool, we need that type info. And we want to convert it to an external ID that's declared by the account manager project. So let's step in and see what happens. Destination value is null. Yeah, we know that. So if source value is null, there's nothing more to do. We're just going to return a null. Source value is not null. And we're receiving that source value as a nullable object, which means I can basically pass anything into here and it'll try and map it, as long as the source type and destination types are compatible with each other. So if the map method cache, and this is another one of those let's make it suck less for the computer things that I did. So I'm creating a tuple of the source type and destination type. And what a tuple is it's a single value that's composed of some arbitrary collection of other values. And I want to use that as a key on an in-memory dictionary. So that I only have to run the discovery code once for each pair of source and destination types. Now I'm going to need a different copy of this method when I go from destination type to source type, but that's okay. That'll be a unique key. But right now the map method cache doesn't contain that key. So it's going to bounce over here because we don't have it. And we're actually going to create that method that's going to get cached, because the exact method we need doesn't exist yet. So we need the entity name. We've got our source entity, external user ID, destination entity, external user ID. We have to make sure that these match. They must match. Otherwise, we're going to get into a world of hurt. Now we get the base map or the base map method. And that method is the map entities function that we came into at the start of all this. But it's just a generic method. It doesn't know anything about the external ID or the user ID resource types that we're dealing with here. So we're just going to get the basic copy of that method and load it into a variable. And then we're going to take that basic copy and use something that's built into the .NET framework called makeGenericMethod. And we are going to actually create a new C# function while the program is running that is a version of this function that works for the types we're trying to map. And I didn't have to write this manually. C# and the .NET framework are smart enough to be able to figure out what I want to do based on the hints I wrote up in that main map entities method. So it's going to run some internal code that Microsoft wrote because they're way smarter than me. And it's going to create a method that we can actually call. So my destination value equals typed map.invoke. We don't need to pass anything for that because it's a static method. And then we're going to pass in an array that is the values that that method is expecting. So let's step in. And we come back out to the plain vanilla map entities that we got to at the very beginning of all of this mapping stuff. And my source instance is a user ID resource. My destination instance is currently null, but that's fine. We know what type it's supposed to be. So what we're going to do, we're going to come in here and it's going to say, oh, yeah, the destination instance, I don't have an object for that, so I better create one. More .NET magic, and I now have an empty instance of the external ID class. Guard types are equivalent. We know they are because source instance has the entity name external user ID, destination instance, it's a different type, but it's also an external user ID. We get the properties, or we get the entity attribute to class property maps. Excuse me. And then we can go steppity boo, get the keys that are in common between the two. And then we just rip through all of this stuff. So I'm going to drop a breakpoint right here. And I'm going to run through because there's two properties and they're basic, right? Here is our new external ID. We've got the ID at vendor. We have the vendor name, which is Microsoft Entra. We can return. We come back out to convert entity value. We've got that destination value, which just came from the recursive call back to map entities or whatever I called it. I can't remember for the life of me. Type map. What's it called? What's the name of this? Map entities. And now, because we actually have a materialized method that we can call whenever I need to convert a user ID resource into a external ID, I'm going to cache this. in a static dictionary that's on the domain object mapper class. And for the rest of the time that this program is running, anytime it needs to convert a user ID resource into an external ID object, it's not going to have to do any of this reflection magic. It's just going to pull that method out of the cache, execute it, and carry on. And that means that as my application runs over time, yeah, it's going to take up a little bit, just a tiny bit more memory every time it adds a new method, but it's going to get faster and faster and faster as it goes. And I have a feeling that the amount of memory it uses, that it accumulates in that cache over time, is going to be much smaller compared to the memory that's consumed when we do all of that build me a new version of this method from scratch thing. And so we're back to convert collection value. There's only one item in that collection. So we're going to come back to the top of the loop. We're going to return our destination list. Here we go. It's got all the things on it that we expect to have. We'll come back out to the root map entity, or convert attribute rather. Go boop, set the destination as assigned, set that new collection of the external ID idiomatic type on the instance of the customer profile idiomatic type of application user. Return that to our conversion to our main map entities method. I think this is the last property that we need to map. We're going to return that instance that we just built, our user profile, and here we are. Here's those external ID. Here's that external ID value. And then we can just return the response. And yeah, that method executed in 19 minutes, 56 seconds, 481 milliseconds because I talk too much. Let's run it again without any of these breakpoints and without any of my yapping. And in fact, because I'm feeling silly, instead of the GeekDad user ID, let's use my user ID. We'll pull a different value. Now this one may not have all the same or all of the values that are necessary because I've changed customer profile a little bit since this guy was originally written. But let's find out. And I'm just going to run it. Go. If it crashes, I'll revert to my to the GeekDad user ID. And I'll debug it in between. Oh, it worked. This time it ran in a little more than 1.5 seconds. And most of that was calling out to Microsoft Entra. And then calling out to Azure Tables. I think all of that reflection goop that we just spent 20 minutes talking over took about 30 milliseconds. Not bad. Not bad at all. And what it means is I don't have to write those darn mapping code anymore. Now, if I have properties on a source object that cannot be mapped automatically to the destination object, I'm still going to need to, or that cannot be automatically mapped using the object mapper, but I still need to transfer them, I can just write an extension method that does that custom transformation when I need it. I'm predicting that this concept, that domain object mapper utility, is going to cover 80% of the mapping cases that I'm going to run into while I'm writing my software. And For the other 20%, I don't mind writing an extension method. It's okay, because it'll just be for the special cases that I can't cover and don't make sense to go in and make that subsys or that utility even more complicated just for those couple of edge cases. So, yes, it does take to use all of the reflection stuff versus the direct object.property equals object.property method that I do in an extension method. It takes, in terms of computer execution time, about three times as long. Using my fancy shiny automatic way takes 2 to 3 times longer than, no, sorry, 3 to 5 times longer than the extension method way. But we're talking microseconds. The extension method time is about 200 microseconds, 250-ish. The reflection way that I'm doing it here is I've measured it against the same data, the same objects, or same types, just different, running it multiple times. It averages between 750 microseconds to 1200 microseconds. So about a half a millisecond to a millisecond difference for each execution. I don't think that's a problem, because yeah, it's going to cost an extra half a millisecond to a millisecond when this executes. But the code that I don't have to write anymore is going to save me hours for each, not hours for each domain entity, but hours of typing and cursing and debugging. Not for each domain entity, but for each idiomatic type of each domain entity. So if it had occurred to me to say, you know what, screw it, let's bite the bullet and write this code now a few weeks ago before I stood up all of these types and gone through the exercise of creating the abstract definition for those types, which, by the way, as we add this stuff, I'm going to be building out these domain definitions, like just as I alter the code. So it's not going to cost me that much more time to retrofit all of this stuff in. If I'd come up with this scheme a month or so ago, I would be many steps further along the path of having my admin system built than I am today, because all of that mapping code takes a long bloody time and a ton of, oh crap, what did I call that over here? And what's that property type? And am I getting this right? And then you run it and you curse because it blew up or it didn't get everything and so on. And it's going to save me over the course of, I'm going to say I've got probably 2, 3, 4 weeks of development on the admin subsystem ahead of me. Instead of 2, 3, 4 weeks, I would have to guesstimate I'd need to add 25 to 50% more time if I were continuing with manual mapping. So 25 to 50% time savings of a developer's hours, and you all know how much you make per hour. Half a millisecond versus $8,000 to $16,000 over the course of a month. So let's say these methods get called a million times over the course of a month. We're talking about a performance difference of half a second to a second, cumulative, over the course of the month. Because remember, the difference is in microseconds. So half a second to a second in performance difference over a month versus $8,000 to $16,000 to pay your developer, to pay one developer, times how many developers do you have working on the project? I'm gonna automate it, even if the automation is a little bit slower than doing it manually. So I've probably just sold you on the idea. I'm not going to ask you to buy this. Once I've done a little bit more dog fooding, which we're going to do in a second, or we're going to do this afternoon because I've just hit an hour, I'm going to be taking this domain object mapper and the filter utility and copying it out of the local copy of the system framework that I'm using here. And I'm going to synchronize CollectionUtilities and DomainUtilities back over to the main thatDeveloperDad.ifx repository. That code base is on GitHub. It's under the MIT license. And it gives you basically a way to use this sensible, this opinionated and constrained but sensible architecture style that I like, and have it be mostly invisible to your developers. Because the only time you see evidence of that framework is when you actually invoke it or when you are declaring your contract types. So customer profile has these entity decorations on it, but that's it. When I'm writing the code that uses them, I don't see it. It's all hidden away. So over on Customer Account Manager, we don't really see that the dependency injection is hierarchical, and that iUser identity access and account access and catalog access, if I were to stand up another manager, I wouldn't be able to just suck those into that manager without talking to somebody else on the team and saying, hey, can I use this here? And how do I use it here? Okay, well, let's get our architect to configure that. And you're able to maintain control over the sanctity of your architecture using this framework, I'm going to say. And keep your team out of trouble. I am my team. Keep me out of trouble. And of course, you got the collection utilities, which has a filter concept in it that I developed earlier this week. This mapping utility that I think I started in on it Wednesday, and then I got it mostly finished yesterday. And I'm going to dog food it this afternoon by applying it to more of the contracts that my components define. And then I'm going to port that over to the main framework over the weekend. And that framework is MIT licensed, which basically means download it, copy it into your project if you want it, change it to meet your needs, and go for it. So yeah, I'm giving this away. If you want to buy me a coffee, there's links. If you want to hire me, there's links to my LinkedIn. And yeah, I talked a lot, and we stepped through a ton of code. And if I do say so myself, this and all of the stuff around it, and the fact that the how do I make it work in my software stuff is largely invisible outside of your design and your contracts. This is some of the slickest code I've ever written. if I do say so myself. I'm very pleased with this. There's one alteration I need to make in the mechanics, and it's to take these dictionaries from just the regular dictionary of type and string and the other dictionary, and I want to turn them into concurrent dictionaries, which makes them thread safe, which means when I've got 1,000 threads running on my server, and two of those threads come into this object mapper at the same time, and one of them is trying to read one type, and the other one's trying to write another type. The concurrent dictionary's got some code inside it from Microsoft that forces those two things to take turns and protects the internal data in memory from two things trying to write to the same stuff at the same time, and so on and so forth. So I'm going to be adding that stuff in between now and this afternoon. And then this afternoon, I'm going to just keep applying this to these component types so that I can eventually delete a whole bunch of code and go faster later as I continue to add features and more contracts and stuff like that to this system. So until this afternoon, take care of yourselves. It is Friday the 13th. Don't walk under ladders. If you see a black cat, stop and give its head scritches. They love that. I have two around here somewhere. I am going to go give them the wiggly scritches as soon as I can. And I'll see you all this afternoon. Happy coding.